Hello, students. Last lesson, we learned about the charging conditions of incoming line BZT. Today, we will learn about the discharging conditions of incoming line BZT. First of all, let's ask a question. What is the BZT discharging conditions? That is to say, to meet the charging conditions, my BZT can carry out logical judgment and has been able to operate so to meet the discharge conditions. The BZT does not have the conditions for operation. Let's combine the typical sectionalized configuration diagram to explain. The diagram shows incoming line 2 supplying power to two buses, that is, two incoming circuit breakers, 1DL and 2DL, for 1 and 2 buses respectively, and one bus tie section circuit breaker 3DL. So, what are the discharging conditions? The first is the voltage. The first discharging condition is that the 1 bus or the 2 bus does not satisfy the condition of having voltage. That is to say, the voltage UX1 of the 1 bus is less than the voltage setting, or the voltage UX2 of the 2 bus is less than the voltage setting, and there is no voltage on either bus. The BZT will discharging. In fact, the charging conditions of the BZT and the discharging conditions, those charging conditions are satisfied at the same time. The BZT will charge. The discharging condition is all relationship. That is to say, any one does not meet. The BZT will discharge it. The second discharging condition is that incoming lines 1 and 2 do not satisfy the condition of having voltage. Under normal circumstances, the BZT is in preparation for work. 1DL in a subposition, in a hot reserve state. The incoming line 1 is a state of voltage, but all the loads are carried by the incoming line 2. So, the incoming line 2 also has voltage. If when the two incoming lines in which one of the voltage is not met, it does not meet the conditions of the voltage, the BZT needs to discharge. The third discharging condition. First of all, 1DL is in the closed position. Then, for the incoming line BZT, the bus sectional circuit breaker must be in the closed position. Any one of the incoming lines is in the closed position. The other one is in the subposition. The figure shows the incoming line 2 through the 2DL to take all the loads to operate. If at this time the 1DL is in the closed position, it does not satisfy the judgment of the circuit breaker's position. Then the incoming line BZT will discharge it. The fourth discharging condition is the manually tripping of 2DL and 3DL. That is, I artificially trip the circuit breaker of 2DL or 3DL. Then, the BZT is also required to discharge. For example, in order to maintain line L2, I artificially disconnect the 2DL circuit breaker, and according to the logic, the BZT operates and closes the 1DL. Then, the need for manual tripping is not satisfied. When I manually trip the circuit breaker, I need to disconnect the power to go for maintenance. And the BZT action condition is to trip the circuit breaker for protection. So, when I manually trip the 2DL or 3DL circuit breaker, the BZT needs to discharge as well. The fifth one, the incoming line BZT trip failure. That is, When the incoming line BZT needs to act, it should trip open the 2DL circuit breaker and then ensure that whether the 2DL is in a sub position. If it is not in a sub position, then it shows that the trip failure. The BZT will discharge directly. The sixth discharging condition is that the TWGs of DL1, DL2, and DL3 are abnormal, and the incoming line BZT needs to capture the positional information of these three circuit breakers, and it actually captures the TWGs of these three circuit breakers. When the TWG equals to 1, it indicates that the circuit breaker is in a sub position, and when the TWG equals to 0, it indicates that the circuit breaker is in the closed position. When captured normally, 1DL is in sub position. The TWG of 1DL is 1, while 2DL and 3DL are in closed position. The TWG of 2DL and 3DL is 0. When the collected information is different from the above, it means that the collected circuit breaker position and the actual circuit breaker position do not correspond to each other, and the BZT needs to discharge at this time. The seventh discharging condition is that the BZT protective action exits. That is, once the BZT action exits, then the BZT discharge naturally. The eighth, control word or soft pressure plate exits. There are incoming line BZT control words or soft pressure planes inside the unit. When I exit the control words or soft pressure planes, the incoming line BZT is discharging as required. The ninth, there is an external blocking signal for digital input. When the external blocking digital input signal comes in, the BZT needs to discharge. For example, the main transformer protection acts to trip. When the time that the main transformer protection acts, it will send a blocking digital input to the BZT. And after the BZT receives this digital input, it will automatically discharge, which is the main transformer protection acts blocking the BZT, such a discharging condition. In fact, BZT's discharging conditions are basically the same, regardless of which device, but a few devices have their own special discharging conditions. These 9 items basically cover all the devices' common discharging conditions. When we are in the commissioning, it is best to keep these discharging conditions in mind. And then, combined with the manual, you will be at ease when commissioning. That is all about the discharging conditions of BZT. Okay, class? Today's lesson is over. See you in the next class.